Hello, Straight Maths, Enrichment. A few people asked me to do more stuff on trigonometry. I've recorded a total of 4 lectures. This is lecture number 4, but I don't know in what order I will upload them. So this is the question. I will explain what it says. It's coming from the Whole and Night book on trigonometry, a very old textbook, well over 100 years old, that I possess. And this is what it says. We have this equation here. X times the cos of half arctan of 2 is equal to the square root of phi. This is an equation for x. We're trying to find what x is, and the phi is what perhaps some of you already know is the golden number or the golden section, which is the positive solution of this particular equation. Okay, and it says at the end, give the answer x is equal to the mth root of n, where m and n are positive whole numbers. So quite something, quite a difficult question. Once you get going, it's not that bad, but it's a lot of information, a lot of scary stuff to thrown at us in one go, and we need to tidy our thoughts. This is where I'm going to start with this. First of all, I'm going to look at this particular thing. I don't actually quite remember now what is phi. I know it's got square roots of 5. So I'm going to find what phi is in exact form. So x squared minus x minus 1 is equal to 0. By the quadratic formula. I'm also going to write something else that comes to mind up there. It's going to be x is the positive square root, the golden number, is positive 1 plus, not plus or minus, plus the square root of 1 minus 4 times 1 times 1 is 1. It is this number here. Okay, so this is your phi. So it's the positive solution. I can actually say phi is this number here. And I'm going to write another fact about phi, which in the past I've used several times in questions that involve the golden number. If you rearrange this equation as x squared is equal to x plus 1, the phi has the property that phi squared, when you're squaring this number here, it's exactly as taking phi and adding 1 to it. Okay, so these are facts. I don't know what I'm going to need up there, but I wrote this fact just in case I need it. So at least now that's quite ugly, because the equation says the square root of this quantity is an utter mess. So where do I start? Okay, probably I need to break this into smaller parts. I'm going to look at this number. The equation is very simple actually. The equation is x is this mess divided by this mess. I just need to simplify them. Okay, there's not anything complicated to solve equation wise. It's just dividing that across. It's just a fancy way of saying solve this equation. Just manipulation of trig really, and surds by the looks of things. So let's work an expression for this coefficient. Can that simplify? So I need to work out what is the cos of a half arc tan of 2. Okay, you can think of inverse trig functions as angles. All right, so you can actually say that is the cos of theta in there. Okay, so you can say, okay, that's the cos of theta, where evidently your theta is your half arctan of 2. So I'm going to take this line now and I'm going to manipulate and somehow hopefully get an answer for this cos of this quantity. So I can say, okay, quite clearly 2 lots of theta is equal to the arc tan of 2. What do I want to do next? I want to get rid of this arctan. So I'm going to tan both sides of this equation. The tan of 2 theta is quite clearly 2. And somehow I need to go back into coses. Okay, how will I go from a tan into a cos? The way I go from a tan to a cos, I'm thinking of going to sex via an identity and then of course the sec, flipping it to go into a cos. So I'm not quite sure if this will work, but we'll try it. Otherwise, my second tool that I'm thinking, if that doesn't work, is an alternative and a variant really. Is actually to work with the right angle triangle. The problem is this to theta, and then I have to change into thetas eventually, because I've got the cos of theta in there. That's my problem. That's why I prefer identities here. So I'm going to square this. Tan squared of 2 theta, quite clearly, is 4, squaring both sides. I'm going to add 1 to both sides of this equation. Why am I going to do that? It's because I'm trying to create an identity, and now I'm getting to smile a little bit, because 5 is a good number in this question. I got 5s, and in a minute it's going to be square roots of 5, because of course that's the sec squared of 2 theta, identity, is equal to 5, which means the sec of 2 theta is the positive square root of 5. We're working with inverse trig, which is defined for positive. It's a 1-to-1 function. There's no minus in this particular case. So where do I go from that? Well, I can write, of course, the cos of 2 theta is, of course, 1 over the square root of 5, which, if you rationalize the denominator, will be root 5 over 5. And remember what I'm trying to do. I'm trying to find what is this quantity. This quantity is the cos of theta. I've got the cos of 2 theta. I think I'm going to get it, because identity, the cos of 2 theta, is, of course, I'm going to write there now the root 5 over 5, but the cos of 2 theta needed in coses is 2 cos squared theta minus 1. That is the same as that trig identity. So that is equal to that, and that is still equal to root 5 over 5. Still very scary. I'm going to add the 1 to the right hand side. So it's going to be root 5 over 5 plus 1. And then I'm going to divide the 2. Shall I put it perhaps over the same denominator first? 2 cos squared of theta is equal to root 5 plus 5 over 5, which means the cos squared of theta will be that divided by 2, so it's out of 10 now. Square root of 5 plus 5 over 10. And again, the cos of theta is the positive square root of that. Okay, so the cos of theta is the plus. And now we have a square roots within a square root. Very scary. But we have actually worked something out. I'm going to put it on this side of the board so we don't lose track of what I was doing up there. I did in the middle of this calculation explained. The cos of theta is that. What is the cos of theta? This, which is this part here. So I have an expression for this, for the coefficient of x basically. The cos of half arctan of 2 simplified, if you can call it simplifying, it looks very scary, is the square root of 5 plus 5 over 10. Just checking before I wrap things off. Okay. I hope this leads to somewhere, because it was a lot of work. It looked quite cool when we're doing all of this. It'd be a real shame if it's not that we've done something wrong. It's just that if we hit a brick wall, it's part of problem solving. All it means, if that doesn't work, we'll try something else. You're learning even if you don't solve your question. The brain is constantly thinking. Okay, so oops, I'm still gonna step on this cable. Let me now say, let's go and, so we found this bit here. This is of course the square root of this. So we got more square roots within a square root. So let's write first of all, x quite clearly is the square root of phi divided by the cos of half arc tan of 2. Okay. And now let's put the quantities that we have for them. The denominator is what I've just worked out, is the square root that contains inside these quantities here. And the numerator is of course the square root of the golden number, and is 1 plus root 5 over 2. So this is definitely, unless I made a silly error in all of this, conceptually I don't think I made a mistake, and somehow this has to simplify to the nth root of an integer n. Somehow square roots and square roots, I just think, gut feeling, guessing perhaps, that m has to be a 4th root, and I can only think that this n has to be a 5. I mean, there's lots of 5s there, square roots of 5s and things like that. It can't be anything else, but I don't want to guess it, of course. This is no maths. We're going to have to come up with something sensible. Okay, so what's our next step? Well, the next step is kind of obvious. Total waste of a line, I'm supposed to do this. Put it over the whole, a single square root. That's the outer square roots. And we'll simplify the fraction inside. So 1 plus the square root of 5 over 2 square root of 5 plus 5 over 10. All right. Multiply top and bottom of this fraction by 10, just to kill the double fraction. So that's still the big square root on the outside. But now inside the square root, if we times top and bottom by 10, the denominator will be just root 5 plus 5, but if we times this by 10, it's going to make this 5 times larger. So we're going to have 5 plus the square root of 5 on the top. 5 plus, sorry, it's not 5 plus that. Made a mistake in there. Times it by 5 is 5 plus 5 square root of 5. I hope I haven't made any mistake like that stupidly in the workings up to here now. And at the bottom I've got, let's write the number first, 5 plus root 5. Okay, it doesn't cancel, nothing cancels in there. Lots of 5s in all of this. Okay, is it brick wall? Is it time to throw in the towel? That's got to be a 5. It can't be anything else. So to be a 5 in there, that's it. It's actually very, very clever. It is, this cancels. It does cancel. It's very, very difficult because, of course, the brain, when you look at this numerator, quite clearly it says, factorize a 5, man. It's just a 5. It's not a 5 you want to factorize on the top. Have a look at it. You want to factorize the square root of 5 from the numerator. Look what happens. When you factorize a root 5 from this 5, you're left with a root 5. That's from this bit here. Root 5 times root 5 is 5. When you factorize a root 5 out of this, you end up with 5. Okay? Look at the bottom. We got 5 plus the square root of 5. Boom, boom. And of course, it is what I thought, gut feeling, of course. I think if you were to, somebody just holding a gun to your head and say, just come up with something sensible, I would have said the 4th root of 5 there. And of course, it is what it is. Is, of course, the square root of 5 square rooted again, which of course is 5 to the quarter, and therefore that is the 4th root of 5. Therefore, your m is equal to 4. And the n is equal to 5. I thought this question was quite nice and quite disgusting at the same time, but I did thoroughly enjoy it. He almost had me at a couple of places, but I did enjoy it. I hope you enjoyed it too. Who's laughing now?